There we cannot use light to study the solar interior. Light does not get past the photosphere, but we can use sound, and the sound which is trapped inside the sun. The sun is actually filled with sound, but there's only very specific tones that are present, so you can consider the sun to be a huge musical instrument. We can see these sound vibrations in the photosphere, and we use them to study the layers below the surface, and this is called helioseismology. The fact that the sun was filled with sound was discovered about a little over 50 years ago now, when observations were taken of the photosphere, and it was realized that the photosphere was moving up and down periodically, with a period of about 5 minutes. It took about 15 years after that to figure out what was causing that. It had to be some sort of mechanical wave, by which we mean either sound or, like you see on the surface of the ocean. After much modeling and observing, it was finally deduced that these are indeed sound waves. The sound waves are caused by boiling, by the same thing that makes your tea kettle or your water in your saucepan make noise as it boils. I don't mean the whistle of the tea kettle. I mean the sound of it bumping and round. The sun is boiling at its outer edge, and that sound is going everywhere, including back inwards. And there's essentially because the temperature changes as you go inwards, it gets hotter as you go inwards. Basically, you have a mirage is created. A mirage, very much like when you're driving down a hot road. You see down the road looks wet. That is because it's very hot near the road and it's reflecting back the light upwards. Same thing happens to sound inside the sun, and the upshot is you end up with only very specific frequencies that survive, and they are indeed trapped inside the sun. They fill the entire sun with a very specific pattern and a very specific set of frequencies or tones. Analogous to a piano. A piano has 88 keys, so you can make 88 different sounds. The sun has 5 million different sounds, which we can see and measure, and by very precisely measuring the tones of the sound, we can infer what the conditions are inside the sun as a function of the depth, for instance. So like we use light to look at the different layers going outward from the sun, we use sound to look at the different layers going inward in much the same way. Certain frequencies travel more deeply into the sun than other frequencies do. And by taking many of these frequencies and combining them, we can actually make images, sort of like holography in a way. And in fact, we do a form of acoustic holograms inside the sun.